friends, welcome back to the channel. Design information is very important in the RTL to GTS2 flow, and the initial point of design information is the parser view. So when we talk about writing any design information in terms of English sentences, that is a functional specification of the design, and the first level the conversion happens in the RTL. That means the designers from the functional specification put the design information in the RTL. So RTL is nothing but Verilog, VSTL, system Verilog, and all this type of hardware description and verification language. But design information is something which does not only care about the syntax and semantics. That means how do you write Verilog, how do you write VSTL. It is a kind of abstract encapsulation which consists of maybe if I talk about the first level, that is the parser view. Parser view is nothing but when you put the Verilog or VSTL design in place, then you run a parser. It stores all the construct of Verilog, VSTL or system Verilog in a particular bucket or kind of things. So we'll talk about this in this video and why it is important, the design information I will talk about towards the end of the video. So till then, stay tuned. Let's start about the parser level view of the design information. So if we talk about the block level design, that is encapsulated in the module and module construct. So these can be assumed as ASIC, so application specific integrated circuit, and there can be multiple blocks, something like that, small blocks, and they can be encapsulated by a system on chip. So you have a system on chip and then you have multiple small block. Each block is basically represented by module and module block. Now the first level from the SoC to the module, there should be some interface. I will talk about this later, but let's start in the block level, that is the unit level. In block level, what happens is that the design information consists of some input ports and some output ports and some in-out ports. So input port is something that when you are taking some signal from the SoC to the ASIC, it propagates a signal towards the block. So from the outside world of the block, you are taking this information inside this block with the help of input signal. Similarly, in the in-out also, with the same type of port, you can take this information from the SoC. So the story is that what happens that when you do a particular verification and you turn to and you want to switch off one particular block, so from the SoC level, you can easily pass some signals through the input or in-out ports that switch off the logic inside this block. I will talk about the logic level inside this module, but first let's concentrate on the interface of the block. Now there can be some output signal. So whatever you are doing logic inside this block can represent any kind of logic. It can be a memory, it can be arithmetic logic unit or any kind of logic circuit that can have some input from the block from the top level and do some processing inside this and can generate some output. That output is again propagated back to the SoC level or top level interface. Now, not necessarily it is the interface level. Inside the block also you can have different construct. You can have a always block. Always block is something which encapsulate the logic part of the signal. So for example, you write a flop, you write a latch, you can easily write inside this always block. You need to follow the syntax of the Verilog, VSTL or system Verilog, any kind of hardware description language that is available. So inside this always block, you can write some signal, you can generate some flop or latch, and you know that this is the sequential circuit, so you need to have a clock. So this clock can come as an input signal from the top level. So you can make it age sensitive by writing some posage or negage or something like that, and the logic is ready. Now the output of the flop you can again channel back to the top level, that is the SoC level. And not necessarily about this, if you need to switch off this part of the module when you do a top level SoC testing, you can do that by taking some set reset signal as a port interaction or port interface of this module. You can propagate this set reset signal. You can write this inside the always block sensitivity list. If reset is there, then you set all the values of the output as 0, or you do not do any kind of operation, so that the previous value will be held in this sequential block. So that you can do. And similarly to this particular module, if I take this as a module A, there can be module B, module C, module D. So similar kind of logic you can think of in this. So the interesting part is that when you actually run the parser basically runs, say for example you run the parser with a particular module A. So parser, typical information that it extract is basically how many input ports are there, how many output ports are there, how many in-out ports are there, and is there any logic inside these. So all this information you can get a gist or summary. So that I am referring as a parser view of the design information. This information is basically eternal till the chip fabrication. So that means that when you start with the RTL and you reach to the GDS2 representation, all these design methodologies basically converting your representation from the RTL level to the GDS2 level. So these input ports, number of input ports, output ports are going to be eternal till GDS2. So that's basically very important to store this information, and this this information is basically, it need to be consistent at every part of the design methodologies till to the GDS2 level, which is a nearby fabrication construct that basically being propagated to the foundry. This is something I told about the parser view of the design in a nutshell. So there can be multiple other views also in the design methodologies that I will talk about in my next videos. And before I sign off, I want to share with you some information that I have recently published a book called Semiconductor for All. So if you are interested about semiconductor, if you are interested about the artificial intelligence, then I would recommend that you purchase this book from Amazon. It is available in the Amazon Kindle version. You can go and visit. The name is Semiconductor for All. And I'm sure that it will benefit you a lot, because it has 25 fascinating topics on semiconductor and latest artificial intelligence trends, essence in this book. So I will mention this book in the description of the video, so you can take it. And last but not the least, I would request you that if you have any particular feedback or any kind of particular comment about this video, or about any kind of topic that has been discussed today or even before, you can put it in the comment section, so that I can be take care of our things. So with that, Subhasish Chakraborti signing off.